Now let's just move on further with the question number 2. It says a vessel is in the form of the inverted cone. So let us suppose if I am just taking the figure of this one. So this is an inverted cone, as you can see. Its height is 8 centimeter and radius of the top, which is open, is 5 centimeter. So let us suppose if I am just writing it out over here, that what are the things that are given to us. The height of this is nothing but 8 centimeter. This is nothing but h is nothing but is equal to 8 centimeter, and its radius. So let us suppose if I am talking about the radius, so its radius is given to us, which is nothing but 5 centimeter. Further it says it is filled with the water, as you can see, up to the brim. When the lead shorts with the water up to the brim, so it is, you can see it is filled with the water up to the brim, and when the lead shorts, each of which is a sapphire, you can see there are the lead shorts which are in the form of the sapphire over here, that are nothing but of the radius 0.5 centimeter. They are dropped into the vessel. 1/4 of the water flows out. So the question actually says that when the lead shorts that are each of the radius 0.5 centimeter, they are dropped into the vessel, 1/4 of the water actually flows out of this particular inverted cone. So we have to find out the number of the lead shorts that are dropped in the vessel. So let's just find out the solution of this one. First of all, let's just write what are the things that are given to us. So the solution of this one would be like, let's just start with the finding out the volume of this particular inverted cone. So the volume of the cone would be like, let us suppose if I am just starting with the volume of the cone. The volume of the cone is nothing but is equal to 1/3 pi r square h. We know that the volume of the cone is nothing but 1/3 pi r square h. Now let's just plug in all the values over here. Let us suppose if I'm just taking the pi remaining as it is, we have pi/3 radius. Radius is nothing but 5 whole square, and the height is nothing but 8. So this is actually nothing but pi/3 into 25 into of 8. So let us suppose if I'll multiply, so this would be 4 and 0. And further we have the 16. This 16 and 4 is nothing but 200. We have this as 200 pi/3 centimeter cube. Always remember that the units are always in cubic formation whenever we are talking about the cube. So this is nothing but 200 pi/3 centimeter cube. This is the volume of the cone. Now let's just talk about volume of the water that actually flows out. So the volume of the water that flows out, it is given to us according to the question. According to the question, it is given to us that it is nothing but 1/4 of the water in 1/4 of the volume of the water in the vessel that we have, and we know that the volume of the cone is just same as that of the volume of the water. So this is nothing but the volume of the water. The volume of the water is just same as that of the volume of the cone, because the water is filled up to the brim. It is filled up to the brim. It means that the volume of both of these are actually is equal to each other. So hence from this particular formation we can say this is nothing but 1/4 into the volume of the water. This is nothing but 200/3 pi. Now let's just sort it out. This value, this would be nothing but 50 pi/3. You can see this is 50 pi/3 centimeter cube. This is nothing but the volume of the water that actually flows out. Now let's just talk about further the volume of the lead shot. So let us suppose if I'm just starting with the volume of the lead shot. So the volume of one lead shot is nothing but is equal to 4/3 pi r cube. Since we know that it is a sapphire, so this is nothing but 4/3 pi r cube. So let's just sort it out. This would be nothing but 4/3 pi. Let us suppose if I'm just taking the pi as it is, and the radius, it is given to us in the question that the radius of the sapphire is nothing but 0.5 centimeter. This is 0.5 centimeter. So this is 0.5 whole cube. This is 0.5 whole cube. Now as you can see, this is 4/3 pi. We have 0.5 0.5 whole cube. Now let's just sort it out. This is nothing but is equal to 4 by 3 pi. This is nothing but 5 by 10 into 5 by 10 into 5 by 10. We have 3 times. Again further let's just sort it out. This is 5 and 1 and 2. This is nothing but 2 and 2 is 4, and further we have 2 and 5 is 10. We have 5 and 5 get cancelled. We have 5 and 1, 5 and 2. So this is nothing but actually is equal to pi by 6 centimeter cube. So we are getting the volume of one lead shot as nothing but is equal to pi by 6 centimeter cube. Now we just have to find out the number of the lead shots that are dropped in the vessel. So whenever we have just such kind of a question, when we have to find out the number of the lead shots, then there is a formula which is related with it. So the number of the lead shots is actually nothing but is equal to the volume of the water that flows out divided by, always remember, whenever we just have to find out the volume of lead shot, so it is always is equal to the volume of the water that flows out divided by the volume of one lead shot, So let's just plug in all the values over here. Volume of the water that flows out is just same as that of the volume of the cone. So this is nothing but 200 by 3 pi whole divided by volume of one lead shot. This is nothing but pi by 6. Now let's just cancel out the values, whatever is getting cancelled with each other. So since we can see this would be nothing but pi and pi get cancelled with each other. This is 200 into 6 divided by 3. This is again 3 into 2 is 6, which is nothing but is equal to 400. So hence it implies that the number of the lead shots are actually nothing but is equal to 400. This is nothing but the answer for this particular question. So this is the answer, and this is really an important formula that you have to remember always. Whenever we just have to find out the number of the lead shots, it is always is equal to the volume of the water that flows out divided by the volume of one lead shot. So this is nothing but the answer for the question number 2. Now we just have to find out the number of the lead shots that are dropped in the vessel. So always remember this formula, that whenever we just have to want to find out the number of the lead shots that are dropped in a vessel, it is nothing but is equal to the volume of the water that flows out, divided by volume of one lead shot. So always remember this formula. This formula always helps us to find out the number of the lead shots. So let us suppose if I'm marking it as star, this is an important formula. Now let's just plug in all the values over here. So first of all, we have the volume of the water that flows out is nothing but 50 pi by 3, and further we have the volume of one lead shot as pi by 6. So you can see pi and pi are getting cancelled, 3 and 2 are getting cancelled. This is nothing but 50 into 2, which is nothing but is equal to 100. So at the end, what we are getting the number of the lead shots as nothing but is equal to 100, and this is nothing but the answer for this particular question.